Hello everyone, thank you for attending to this new webinar. Today we will talk about CivilFEM for ANSYS mechanical APDL and concrete structures design. We will show the capabilities of CivilFEM, the different products. Later we'll show some examples, and if you have any question, please use the application tool. We developed three products of CivilFEM. One is CivilFEM powered by Mark, using Mark Solver, product from MSC Software, which is now from Hexagon. The graphical user interface is fully developed by us, so it's very user-friendly. And then powered by MSC Software. Okay. Now Mark Solver is a very powerful nonlinear solver. And today we will show the capabilities of CivilFEM for ANSYS. It's a ANSYS add-on for ANSYS mechanical APDL. Okay, so this add-on works fully integrated in ANSYS graphical user interface. And there's an ICT extension from the ANSYS catalog store, which is CivilFEM for Workbench, which has less tools and capabilities than the other two products.
Well, today the webinar is going to be about CivilFEM for ANSYS mechanical APDL, and especially the capabilities for the design of concrete structures. CivilFEM for mechanical APDL, for ANSYS mechanical APDL, is an add-on, and CivilFEM is adding more than 400 capabilities to ANSYS, and they are focused on civil, structural, and geotechnical engineering. So it's a customized version of ANSYS mechanical APDL for the civil, structural, and geotechnical field. How it works? Well, it is adding new capabilities, so it's like having extra command and extra capabilities. So you have access via menu in the ANSYS graphic interface, or using commands. So you can mix CivilFEM and ANSYS command and working with just one unique software. So, some examples that have been done with CivilFEM for ANSYS are some of these plots, bridges, tunnels, dams, and with the powerful ANSYS solver, plus the capabilities that are added by CivilFEM. Here we have some other examples, some offshore structures, also structural buildings, wind turbines, foundations, and also tunnels. Also, there's some capabilities for nuclear power plant, for the nuclear power plant containing building, and also the rest of the structures with nuclear power plant codes and standards to check and design, and the steel and the concrete part. Well, today the main capabilities that we are going to see are related to concrete structure design, and we are going to see three examples with where we are going to see capabilities for the construction stage process and time-dependent material properties. So we can model with CivilFEM plus ANSYS, we can model any stage process, the construction, plus the time-dependent material properties. CivilFEM modify the material properties, which are time-dependent, and update the mechanical properties, and considers the concrete age. Also, we will see three examples with beam, cell, and solid elements, and the capabilities of CivilFEM for checking and design those structures under international codes and standards. And also we will see also capabilities about prestressed concrete. Capabilities of CivilFEM to define tendons, also automatic calculation of short and long-term losses, and how CivilFEM transfer those equivalent loads to beam cells or solid element models. So the examples we are going to see is a cut-and-cover tunnel, where we have solid elements for the soil and set elements for the concrete part, a concrete box bridge, which is made of beam elements, and also a wind-turbine foundation made of solid elements. We are starting with cut-and-cover tunnel. In these examples, we are going to see the construction process with the excavation and the construction of the concrete part and the fillings around it and overloads on them. This is a tunnel sometimes under an airport. And in this part that we are going to see is a 3D model, because we have just this asymmetrical structure on top of these tunnels. So we need to perform a 3D model. We have already solved the model, but here you can see we have the different parts of the model, and we are going to solve 5 different stages. First, the soil with the excavation, then the construction of the concrete, the fillings on top, first around the concrete cells, and then this other part, and applying loads. Here you can see that we have used this macro, and here we are combining ANSYS and CivilFEM commands. The CivilFEM commands are similar to the ANSYS ones, that have some arguments that are describing what we are doing. In example, this is for generating a material model. So material model number 1, which is from the CivilFEM library. CivilFEM has a extended library with code and standard materials. And in this case, we are selecting from the Eurocode 2 a concrete, a steel, and different soils. So here in the software, you can see that in the civil preprocessor, we have materials with the material library, where we can select all these materials, and all the properties are automatically defined and set into ANSYS. Well, the construction process, we can see here with these commands at the end. Just is first the excavation part. Sorry, that is.
You have to go to post-processing,
where we just build the concrete part. Then the second stage is fillings around the concrete structure. Another stage.
This part is the first cuttings.
Where this is filled. And the last part, the structure for the airport.
And then the cover.
And the last stage is adding some overloads on that part. So the model is exactly the same, but with some overloads. For this, in this case, what we have done is performing the concrete design, considering every of these load steps. So the steps here to do that is reading the load step we would like to design. So we can read the first load step in example, and here in code checking we perform the code structure. We have several codes and standards. Here you can see that you can select for steel, concrete, prestressed steel. So you have a long list of codes. In this model we are using the Eurocode 2 to design it. So the selected code you will find here at code checking, and you can perform for concrete checking or design. If you are checking the model, you have previously defined the reinforcing groups on the sections, and then you calculate CivilFEM just check if that reinforcement is okay or not okay. The design part, what CivilFEM does is calculating reinforcement amount for the different load combinations. In this case, what we are solving is the different load combinations, the 5 states, the 5 phases we have for the construction of these tunnels. So we are reading every of these load steps and designing, that is calculating reinforcement amount. After designing the 5 load steps, we create an envelope of those results. So we can do it by commands in a very easy way. We are reading the 6 load steps, and with this command, dimension of concrete, designing of concrete, the cells, we calculate reinforcement amount, and finally we calculate an envelope. So if we read that envelope, we can plot the results. I'm going to select first.
As you can see, the use of loops and conditional statements are very powerful for APDL. Of course, you can always use the graphical user interface, but in the mechanical APDL environment, the APDL scripts are...
Well, this is the concrete structure. Here we have the tunnels, and there's a wall on top of that. We have only designed the tunnels in this example. So we are going to plot some of those results. So here we can see CivilFEM results for reinforcement amounts. That is the calculation of the reinforcement amount in the different directions X and Y, top and bottom of this concrete structure. So that is done by command. Also we can plot those results here using the graphic interface. And in example, we are going to plot reinforcement amount in bottom X direction that is calculated by CivilFEM. And here we have the values of those results. Here in examples, we are having these values are plotted in the user units. In this case, is square meters per meter. So that is equivalent to 0.0014. It's equivalent to almost 15 square centimeters per meter. This is the reinforcement amount that are needed on these all directions. So after checking the 5 stages, the 5 load steps, and calculating the reinforcement amount and the envelope of maximum reinforcement amount, what we can do for a serviceability limit state is then just set in the preprocessing part. In the different parts of the model, we can select different element groups, and we can assign different reinforcement groups. That is in those cell vertex. We can define different reinforcing groups. That is, in this case, in the different directions, X top, X bottom, Y top, Y bottom, with different mechanical covers. We define reinforcing in terms of bar diameters and spacing. The spacing are 15 centimeters, and the diameters are 25 millimeters in X top direction, and in the rest of the directions 20 millimeters. So after defining in the model are reinforcing groups that fulfill the reinforcing amount that we have calculated, then we can perform the serviceability limited state, that is cracking checking. Then the steps are reading the serviceability limited state combinations and performing cracking checking. So here in the check by code, cracking checking, so we define an allowable crack width. In this case is 0.3 millimeters, and we perform a cracking checking according of the active code. So if we go back to the slides, we can see here we have here the construction process of the 4 stages plus the last one, which is an overload on it. And these are the bending plus axial results. You can see here that is in X direction, top and bottom reinforcement amount that is needed. In these cases are 25 and almost 20 square centimeters per meter. In the other direction, Y direction, we have this top and bottom reinforcement amount. Well, just for clarifying, X and Y directions are the element axis direction. So the user can orientate the cell element axis with ANSYS commands, and CivilFEM will calculate reinforcement amounts following those directions. And well, also shear reinforcing. CivilFEM can calculate shear reinforcement. And the last part is self-reality limit state design cracking checking, and these are some results or crack width that is calculated in X and Y directions, top and bottom. Here in these two plots, we can see in X and Y direction bottom in both cases that crack width is less than 0.3 millimeters. We can see that is 0.28 and 0.29 millimeters. So the structure is okay, and the reinforcement amount that we have designed using CivilFEM fulfills the Eurocode 2 and all the specifications.
Of course, we are only designing the concrete part, but you know that in tunnels we can have bolts, anchors, and and other structures that can be designed, steel or other parts of the wall of concrete. But in this case, we are just showing the tunnel lining or concrete lining. Okay.
Well, now the next example is concrete bridge. In this case, we are going to see the same capabilities, similar to the ones we have seen, but for beam elements, but with another extra capabilities in this case, that is post-tension concrete. CivilFEM has some capabilities for defining the tendon layout, then calculate losses, long-term and short-term losses, and apply equivalent forces and moments to the model. Those forces and moments to the model that are applied to the model can be combined with the rest of the structure and with the rest of the loads, and then check and design the model. So if we go to the models, here we can see this is a beam model. These are beam elements, but they are plotted with the real shape. We can see here that if we don't plot the shape, it seems like a line, and well, plotting the shape, you can see here that the real shape, it is meshed with beam 188, and this model has different cross sections. We can see here cross sections. There is a solid cross section, that is this one, and a hollowed one. We can see here with some hollows. In this case, we have defined reinforcing amount in all the different parts of the model. So what we are doing in this case is checking the structure. That is, under the different loads we are applying, we are going to check if this reinforcement amount is okay or not okay. Instead of designing, as we did in the previous model, that CivilFEM calculates reinforcement amount, in this case, CivilFEM is checking if this reinforcement is okay with the loads we are having, with the combinations we have.
Yeah, we will perform a code verification of the rebar configuration, and we can later adjust different layers of reinforcement.
So for the pre-stressing, we have here some tools that are classified inside CIVIL preprocessor, pre-stressing concrete properties, and then for defining the tendon, we have a tendon editor. In this tendon editor, we have the different cross sections of the model, the cross sections of that is every element cross section, element 1 in one side of the model, 2, 3, and all these ones, and also we have the transition between hollowed and not hollowed sections. And here we have the tendons. With CivilFEM, with this browser, what we do is define the different points of the layout of the tendon in elevation and plan view. In the plan view, we have just 4 points at both sizes, and in the elevation view we have several points to define this shape, this layout. After defining the tendons, we set the properties of the tendons, that is diameter in these 6 tendons. We define material, pre-stressing forces, if we are pre-stressing from one side or the other, in this case from left, and all of this. After that, CivilFEM calculates losses. In this table, you can see all losses in the different points of the tendons. On every of them are calculated initial pre-stressing forces losses, the immediate, long term, and all detailed. These losses can be exported into an Excel file and could be modified by the user and apply again. Well, these loads are applied into the model, the equivalent tendon loads, and in this case we have applied 2 different versions. Short-term. We have initial pre-stressing loads to the model. We have applied them only with the short-term losses that are calculated at CivilFEM, and the long-term losses for a long-term pre-stressing loads. And we have applied some traffic loads on the model. These traffic loads are also defined by CivilFEM. We have here some tools to define the vehicle, different vehicles that follows the codes with the different loads, and also we have also to apply a part of traffic load surface loads and some other tools. And in this case we have simplified all these options and we have applied traffic loads on top, also thermal loads and pre-stressing loads. If we see here the commands, well, this is the model generation, the materials, element types we are using, section definition to define the reinforcement groups, the CivilFEM commands, ANSYS commands to create the model. These are the commands to define the different points and layout of the tendon. So it can be done with commands as well. And finally we have defined vehicle loads, initial pre-stressing, final pre-stressing, self-weight, death load, surface pressure, and thermal gradient. So after defining all these single loads, also CivilFEM has a browser code combination to perform the code combination.
Yes, in this case you have to select the loads first, and if you select the loads, then automatically the type of loads, of dead loads, live loads, will be assigned with the different coefficients.
Yeah.
Okay.
You can this browser depends on the codes you are selecting to define that predefined coefficients and suggest some combinations. So it is different from Eurocode to American codes. Depends on the code you select. In example, for these American code combinations, what you have to do is select the load steps you have solved, and then after selecting them, you have to indicate the type of loads that are them. If there are dead load, live load, roof live, the different types. So after this, CivilFEM suggests different combinations and also creates the equivalent commands and combine all these loads and create new load steps. So after this, you can create all you can check and design all those loads. So we have previously done this with commands, and well, here after combining, we can extract maximum and minimum bending moment envelope, the positive and negative bending moment with this, and we can perform code checking and design. The code combination we have used the Eurocode with favorable and unfavorable coefficients for permanent or accidental loads, and then in this case what we are doing is checking the model. So CivilFEM creates the integration diagram considering the tendons. So this is a post-tension concrete integration diagram, and what CivilFEM does is check the model. That is checking if the reinforcing amount is okay or not okay. And CivilFEM gives a safety factor. If this is less than 1, it is okay. And because what CivilFEM does is calculating the ratio between the demand and the capacity of the structure. So if the demand is greater than the capacity, this value is less than 1. So in this case, what we are doing is checking the model and checking the reinforcing amount that the user has previously defined. And the last example is the wind turbine foundation. In this case, what we are doing is designing a solid element model. In this case, we have solid elements for the model, and we are going to check or design this part. That is calculating reinforcing amount to this model. So it is done through an equivalent cell model where CivilFEM integrates stresses, and then those stresses that are integrated and forces and moments are calculated. Then it can be checked and designed following the different codes and standards that are based on forces and moments instead of solid element stresses. So here you can see the equivalent cell model. These are just dummy cells that are used to save those results. So on every of these cell elements, CivilFEM integrates stresses on the solid elements, just reading the stresses tensors of the model and calculating forces and moments that are saved into this equivalent cell model. And then this equivalent cell model can be checked and designed under different codes. So if we check the model, this is the model. In this case, we have model here in the center, and we have modeled the soil with solid elements and with a geotechnical material model. Here we apply the loads, and we have CivilFEM has created that equivalent cell model. The way to create that equivalent cell model is through a command on here also the utilities and here solid to cell. We can create a new part. So what we have to do is create a component of the elements that where we are going to create those equivalent cells, and CivilFEM automatically create those equivalent cells, dummy cells, where CivilFEM integrates those elements. So well, here we have the components, and CivilFEM creates a component with those equivalent cell model, which is this, and where results are integrated.
Those cell elements have the same thickness as the assigned solid elements. You will see now.
And also the properties are taken from the elements, the solid elements. So well, just here in the Civil Post Processor, we can see we have several load steps. That is the wind loads that have been applied and incremented. So in example, we are going to read some of these results. So in example 20. And then here in these dummy cells, we can plot forces and moments. In example, bending moment around X direction, Y direction. So, well, another special feature of this model is that the element axis has been orientated in a circumferential and radial direction. That is, using a circumferential element axis. So, as we have orientated in those directions, the elements of these dummy cells, CivilFEM will calculate reinforcing amount in circumferential and radial directions. So, well, some of those results we can see here. This is the reinforcing amount in X direction, that is the radial direction, and the reinforcement amount that is calculated, and in X and top and bottom direction. and this is in the y direction. In the y direction, that is the circumferential one. This is the reinforcing amount that is needed. Also, shear reinforcing can be calculated, cracking checking, all the previous CivilFEM capabilities could be applied to these dummy shells. So, well, other solution that have been solved with this is calculate the safety factor. So we have increased loads until the model has stopped converging, and we can calculate the failure of the soil for nonlinear material model. This is yielding on the soil, also nonlinear concrete for the cracking, and also the loads that are needed for the turnover. So we can calculate safety factors for the design loads, increasing them and calculating the failure of this model.
So, as a summary, today we showed the capabilities of CivilFEM for ANSYS mechanical APDL as an add-on to ANSYS standalone installation. But you must know that we have another products, and depending on the utility that you want to use in your projects. Okay, you have another tools, which is CivilFEM for ANSYS Workbench as an ACT extension with some capabilities as the material library, section libraries, checking and design combinations, but all these capabilities that Roman showed before, the solid to shell and other capabilities and material models are only in CivilFEM for ANSYS.
Yes, it depends on the solution. We have different capabilities from CivilFEM. Well, in this case, we have seen some capabilities of CivilFEM for mechanical APDL. For ANSYS mechanical APDL, these capabilities are concrete structure design for cell beams and solid elements. Different capabilities to design models, concrete models that have been modeled with beam, cells, and solids. Also, we have these capabilities for steelworks, and also not only normal concrete, also prestressing concrete, and also, well, CivilFEM has many capabilities for geotechnics, bridges, nuclear power plants. So it is a general purpose software that has a customization of ANSYS for all the civil, structural, and geotechnical projects. Also, well, just for giving you a small information about us, about the company in Cyber, we are especially a civil and mechanical engineering company. We are the developers of CivilFEMs, but we give full support to our clients. We not only develop and sell them the CivilFEM, also we develop tools under demand. If you need any special tool that any other software doesn't have, we could develop for you. Also, we could help you with the modeling and everything, giving you consultancy, just helping you with the simulation, just basic on FEM simulation. And also we can give you some finite element analysis trainings on site, or also we need a master and e-learning platform.
Cyber also offers consultancy services. So if you are interested in the analysis of any type of project for all types of engineering industries, for civil, mechanical, geotechnical, including photovoltaic industry, fiber reinforced concrete structures, even CFD, solid structure interaction, please ask us for any information so we can carry out the analysis you need for your project using any type of software, including CivilFEM, ANSYS, MSC software. The knowledge about finite element analysis and CEA simulation can be shared through our training channels. we have different ways of training. One is the FEM Masters, the International Masters in Theoretical and Practical Application of the Finite Element Method and CEA Simulation. The next course will be the 28th. This Masters includes both fundamentals and practical application with the software. The most important FEA packages, including ANSYS, Prestressed, and CivilFEM. The next enrollment dates are September of this year, 2022, and the next year, in April, there's a extraordinary enrollment date. You can visit this webpage for further information, or you can ask us through email or by phone, or follow our social media. And another way of learning is the International Online CEA Education Center. In this case, only practice with the FEA software is included, totally e-learning, and it's with flexible schedule, so it will be studied at your pace and your own convenience. So you can start the course anytime. Just visit this website so you can see all the available courses. And there's a free FEM course always available, so you can check it out. And of course, if you need any customized course online or on site, please ask us for further information, because we can create any tailored course for you.
And well, here you have some of our websites, and if you would like to try CivilFEM, we have also some student version and some just some 1 month licenses you could use for checking CivilFEM. And if you have any doubt, or could you like to have any, you can just please feel free to email us and to ask us about any doubt you could have and any question you could have about CivilFEM. And of course, please complete the survey. It will be very useful for us to improve our webinars and the information and the develops we do in our CivilFEMs. Thank you very much for your attention.
Thank you. Bye-bye. Stay tuned.